Let's talk about LeetCode 3071 minimal operations to write a letter Y on a grid. So for initially this grid, this is a n multiple by n grid, and this kind of n is an order number. Um, where does it say? N is order. And so y is what is y? Y that is he consider, for example, this one is y. That is the diagonal start from top left cell and end at the center of the cell. So this is n divided by 2 and n divided by 2, right? This kind of position. And the diagonal start at the top right and in this kind of direction. And the vertical line from this center to the bottom. So we need to get all of the value belong to y are equal. And all of the value not belong to y are equal. Initially, there is 0, 1, and 2, right? And you can for this you can put, for example, all the numbers in y to be choose one of this right to be the same, and all of the rest to be the same. So retain the minimum number of operation you need to write the letter y uh, on the grid, so that you can change the value to any 0, 1, 2, right? So it will ask what's the minimum number of operations we need. So the thing is that in the end, there were only left two type of value, right? 1, 2, 0, 1, 2. We can only use two of that. And every number on the y should be the same. And not on the y should be another number. So ask the minimum number of changes we need. So the thing is that we just actually just do this question based on what is asking, right? So we just iterate. We need what we need is that we need to count on y, for example, the 0 count, 1 count, and 2 count, and not on y, the 0 count, 1 count, and 2 count, right? We can have a count array, right? And then we just have the combinations. For example, y choose 0, and non-y choose 1, non-y choose 2, right? And y choose 1, non-y choose 0, and non-y choose 2, and y choose 2, non-y choose 0, and then non-y choose 1, right? We find the minimal operations. So let's just write code for this. Int n equals grid this is n multiplied by n a square, right? So we know this y count, how many for those kind of cells, right? How many cells? So we'll see, because this one will be n divided by 2. Actually, this line will be m divided by 2, right? This will be m divided by 2, and there is one missing, so that will be 3 multiplied by n divided by 2 plus 1, right? So total count for y is 3 multiplied by n divided by 2, and the non-y count is n multiplied by n minus y count. So we need just count this one, right? So we should have a count array equals new into 2 multiplied by 3. So what we do is for int I equals 0, I smaller than I plus plus. For int j equals 0, j smaller than n, j plus plus, right? So we'll write a help function if is on y, right? So I j Then we're going to have counts 0 and grid I j increase by 1, right? Else we're going to have counts 1, right? This is not on Y, grid I j should increase by 1, right? So in the end, what we need to do is we want to find a minimal result, right? So we'll have int result equals integer dot max value. We'll have 4, right? So every um, we iterate every possible combinations for int I equals to 0, I smaller than 3, I plus plus, and for int j equals 0, j smaller than 3, j plus plus, right? So we know those kind of y number and non-y number, they cannot be the same. So let's say if I equals j, we just continue, right? And then we're going to result should be equals mass dot main result. They have y count minus counts 0. That means for those kind of on y we change to I, right? And also plus the non-y count minus counts 0 changes to j, right? And in the end, we just return result, right? So we need a help function, whether it is on y or not. Private Boolean is y. Int n, don't need even the grid. Int row, uh, int column, right? So that means that let's look at the y. It can have 3 scenarios. One is column is smaller than 2 over n. One is column is equal to 2 over n, right? And one is greater than 2 over n, right? So we just consider this kind of scenario, that is if column is smaller than n over 2, then we need return row should equals to column, right? If column is greater than n over 2, we just need to return I row equals n minus 1 minus column. And for those kind of this part, right, equals, then we just need to return um, row greater equal to n over 2, right? So this will be the code. Let's take a look. This y is not it should plus 1, right? We mentioned this should plus 1 because this is 1 over n, this is 1 over n, this 1 over n, and then we need to add the center one, right? One is and count with ij count 1. Mean this is count 1. Okay. And let's also write Python code as well. So we have n y count. Let's have n first equals the length of grid and the y count and the non-y count equals 3 multiplied by n divided by 2 plus 1. And this one will be n multiplied by n minus, minus this, right? And have a count because this one multiplied by 3 for this one in range 2. Okay. So what we do is for I in range n, for j in range n, we're going to have if is y n I j, we're going to have counts 0, grade I j should increase by 1, else counts 1, grade I j should increase by 1, right? So of course we need a help function is y. Then we have result equals float I f for I in range 3, for j in range 3, if I equals j, continue. Otherwise, we are going to have result equals mean result y count minus counts 0 I plus non y count minus count 1 j, right? And in the end, just return result. Let's define is y, df is y, right? N I row column. So that is if column is smaller to n divided by 2, right? Then we're going to have return row should equals to column. If column is greater to n divided by 2, right? So we return row equals n minus 1 minus column. And for the other case, that is column is the middle one, right? So just return row is greater equal to n divided by 2. So this so this one will also minus 1, right? This because this one add 1. So this one minus 1. Because that is a multiple by n multiple by y counts. The time complexity will be n multiple by n, right? And n square. So the space that is constant.